Hello everyone. This is part 1 of module 2 of the subject of Environmental Engineering 2. The title of this module is Characterization of Sewage. So, in this module, we are covered the composition of sewage, characteristics of sewage in terms of physical characteristics, chemical characteristics and biological characteristics, the decomposition of sewage, that is aerobic decomposition and anaerobic decomposition. So what is composition of sewage? The composition of wastewater varies widely. This is a partial list of what it may contains. In form of water. Water is more than 95%, which is often added during flushing to carry waste down a drain. Next, pathogens such as bacteria, viruses, parasitics, worms, etc. It also contains non-pathogenic bacteria. The maximum contents in sewage is of organic particles such as feces, hairs, foods, vomit, proper fibers, plant materials, humus, etc. The soluble organic matter such as urea, fruit sugars, soluble proteins, drugs, pharmaceuticals, etc. And it also includes the inorganic particles such as sand, grit, metal particles, ceramics, etc. So composition of sewage means the amount of these contents, as we show in previous slide, the percentage of amount of this content in sewage. So as you can see in both the figures, the maximum contents of organic matters, that is approximately of 23 to 28%, which is present in sewage. Means sewage contains maximum organic matters, and the other particles such as plastics, papers, rubbers, any non-ferrous metals or inorganic metals, timber, glass, etc. The percentage of these contents is very minor. So sewage contains maximum amount of organic matters. Then the characteristics of sewage. The quality of sewage can be checked and analyzed by studying and testing its physical, chemical and biological characteristics as explained below. Physical characteristics, which covers odor, color, temperature and turbidity. Chemical characteristics, which includes total solids, pH value, chloride contents, nitrogen contents, fats, oil and greases. And biological characteristics, which includes the most probable number of coliform bacteria, that is MPN, and biochemical oxygen demand. So let me see one by one. So first is physical characteristics. First is odor. The odor of the fresh sewage is not offensive, or practically it can be considered odorless, but as it starts to get stale, it begins to give offensive odor. Within 3 to 4 hours, all oxygen present in sewage gets exhausted and it starts emitting offensive odor by hydrogen sulfide gas, which is formed due to the anaerobic decomposition of sewage. Next physical characteristics is color. The color of the sewage indicates the freshness of sewage. If its color is grayish brown or yellowish, it indicates fresh sewage. With passage of time, as putrefaction starts, it begins to get black. The color of stale and septic sewage is black. When all the oxygen has disappeared from sewage, it becomes a septic. Other color may also be formed. Next physical characteristics is temperature. The temperature has an effect on the biological activity of bacteria present in the sewage, and it also affects the solubility of gases in sewage. It also affects the viscosity of sewage, that is, More is the temperature, lesser is the viscosity of sewage. The average temperature of sewage in India is about 220 degrees centigrade, which is near about ideal temperature of sewage for biological activities. At higher temperature, coupled with the lower dissolved oxygen activities, can cause serious problem in disposal of wastewater. Next physical characteristics is turbidity. So what is turbid water? Sewage is normally turbid, representing dirty water or wastewater from bath having other floating materials like fecal matters, pieces of paper, cigarette ends, matchsticks, grease, vegetable debris, fruit skins, soaps, etc. The turbidity depends on the quantity of solid matter present in suspension state. The turbidity can be determined by the turbidity rod or by turbidity meter called as nephelometer. Next are the chemical characteristics of sewage. Tests conducted for determining the chemical characteristics of sewage help in indicating the stage of sewage decomposition, its strength, and the extent and type of treatment required for making it safe to the point of disposal. The chemical analysis therefore carried out on sewage in order to determine its chemical characteristics. So what are that chemical characteristics? First is solid. Sewage normally contains 99.9% of water and only 0.1% of total solids present in the sewage may be in any of below mentioned form. That is, it may be available in suspended solids, dissolved solids, colloidal solids, and settleable solids. So solids are available in sewage in the form of either suspended solids or dissolved solid or colloidal solids or settleable solids. Suspended solids are those solids which remains floating in sewage. Dissolved solids are those which remains dissolved in sewage just as a salt in water. Colloidal solids are finely divided solids remaining either in solution or in suspension. And settleable solids are that solids which settle out if sewage is allowed to remain undisturbed for a period of 2 hours. So solids can be organic or inorganic. About 45% of solids are organic in nature and remaining 55% are of inorganic nature. Inorganic matter consists of minerals and salts like sand, gravels, dissolved salts, chlorides, sulfates, etc. And organic matter consists of carbohydrates like cellulose, cotton, starch, sugar, etc. Fats and oil received from the kitchen and garages, etc. Also, the nitrogenous compound like protein and their decomposed product including waste from animals, urea, fatty acids, etc. The amount of various kind of solids present in the sewage can be determined as follows. So first is total solids. So how to determine the quantity of total solids in sewage? It can be determined by evaporating a known volume of sewage sample and weighing the dry residue left. The mass of the residue divided by the volume of sample evaporated will give the total solid in milligram per liter. So next is the suspended solids represented as S2. These are solids which are retained by filter of 1 micrometer pores. So the layer called non-filterable solids. Their quantity can be determined by passing a known volume of sewage through a glass filter and weighing the dry residue left. So the mass of the residue divided by the volume of sample will give the value of suspended solid represented at S2 in milligram per liter. Next is the dissolved solids and colloidal solids. The difference between the total solids and suspended solids, that is S1 minus S2, represent the dissolved solids and colloidal solids. Next, the volatile and fixed suspended solids. The total suspended solids, that is S2, may either be volatile or fixed. To determine their proportions, the non-filter residue is burnt and ignited at about 550 degrees centigrade in a muffle furnace for about 15 to 20 minutes. The loss of weight due to ignition will represent the volatile solids in the sample, that is represented at S4. And the difference between S2 and S4, that is suspended solid minus volatile solids, which will give the fixed solid quantity, that is represented as S5. Next chemical characteristics is pH value. What is pH? The pH value of sewage indicates the logarithm of reciprocal of hydrogen ion concentration present in the sewage. And mathematically we can represent it as pH value equal to reciprocal of or minus the log of H plus ion concentration, that is hydrogen ion concentration. It is thus an indicator of acidity or alkalinity of sewage. So pH value represent the either the water is acidic or alkaline. If the pH value is less than 7, the sewage is acidic in nature, and if the pH value is more than 7, then the sewage is alkaline in nature. pH can be determined by using pH meter. So in this diagram, as you can see, the value of pH starts from 0 and end to 14. So value 7 is represented as neutral. That is, if the sewage has the value 7, then the sewage is neutral. If the value of pH is less than 7, then the sewage is acidic in nature. And if the value is greater than 7, then the nature of sewage is alkaline in nature. So as you can see in this figure, there are the pH values of some materials. For example, the battery acids, the value of pH is 0. That means it is very strong acidic in nature. Sulfuric acid is also the very strong acid, that it has the value of 1. Lemon juice, orange, acid rain, bananas, clean rain, milk, etc., which these all materials has the pH value is less than 7. That means these all matters are of acidic in nature. And some matters such as seawater, baking soda, ammonia, soapy water, bleach, liquid rain detergent, etc., which has the pH value is greater than 7. That means these all are alkaline in nature. So you just can try one experiment at your home. You just if you got the pH paper, you can get easily in market or easily available in market. So just you can check the values of regularly used material or food, the pH value of milk, the pH value of soap, the pH value of detergent, the pH value of water. So this is one small experiment that you can conduct at your home. So next chemical characteristics is nitrogen content or nitrogen compounds. The presence of nitrogen in sewage is an indication of the presence of organic matter and may occur in one or more of the following form. Either it can be available in form of free ammonia called the ammonia nitrogen, or which is available in form of albuminate or organic nitrogen, or in the form of nitrites, or in the form of nitrates. The free ammonia indicates the very first stage of decomposition of organic matter. So in the presence of free ammonia, that means the organic contents are present in sewage. The albuminate nitrogen indicates the quantity of nitrogen in sewage before decomposition of organic matter. Nitrates indicates the presence of fully oxidized organic matter in sewage. The nitrites thus indicates the intermediate stage of conversion of organic matter of sewage into the stable form, that is to the nitrate, thus indicating the progress of treatment. Their presence shows that the treatment given to the sewage is incomplete and sewage is stale, whereas the presence of nitrate indicates the well oxidized and treated sewage. The organic nitrogen can be measured by adding strong alkaline solution of KMNO4, that is potassium permanganate, to already boiled water sample and again boiling the same. Ammonia gas thus liberated is measured, which gives the quantity of organic nitrogen. The sum total of ammonia nitrogen is called as Kjeldahl nitrogen. The nitrites are dangerous, but as oxidization of nitrites to nitrate is very fast, it is generally not found in water bodies. But if the sewage contains higher nitrates and if it is disposed of in a water body, then the nitrate content in the water body would increases. Higher quantity of nitrate adversely the health of infant, causing the disease called methanomegalia, commonly called as blue baby disease. So the children suffering from this disease may vomit, their skin color may become dark and may die in extreme case. So as you can see in this figure, that is called as nitrification and denitrification. That means in the fresh sewage, the free ammonia is present. That is, the pollution is just start. When it is decomposing, then the ammonia will get converted to nitrite form. That is the intermediate stage in nitrate and ammonia. So nitrite again decompose or oxidize to form nitrate, which is the stable form of organic matter. So throughout this process, the ammonia or free ammonia, which will get converted to nitrate or the stable form of organic matter in aerobic condition, that means in presence of oxygen. But again, when this sewage will get in anaerobic condition, that is the absence of oxygen, again this nitrate get converted to nitrite and ammonia, and this free ammonia is released into this atmosphere, and this way this process will be continued. The next chemical characteristic is chloride contents. Chlorides are generally found in sewage and are derived from kitchen waste, human feces, and urinary discharges. The normal chloride content of sewage is 120 mg per liter, whereas the permissible limit of chloride content in water is 250 mg per liter. It can be determined by titrating the wastewater with standard silver nitrate solution using potassium chromate as an indicator. Next chemical characteristics is fat, oil and greases. Fats, oil and greases are derived in sewage from the discharge of animals and vegetable matter or from the garages, kitchens of hotels and restaurants, etc. Such matters form scum on the top of sedimentation tank, clog the voids of filter media and affect the diffusion of oxygen. They thus interfere with the normal treatment methods. Hence, this detection and removal is necessary or important. Oils and greases are soluble in ether. Hence, for their determination, a sample of sewage sample is first of all evaporated, leaving behind the oil and grease as a residue, which is then weighted. The next chemical characteristics are toxic compounds. So copper, lead, silver, chromium, arsenic, phenols, boron, cyanides, etc. are some of the toxic compounds affecting the microorganism, resulting in malfunctioning from the industrial waste. The next chemical characteristics is sulfides, sulfate and hydrogen gas. Sulfides and sulfates are formed due to the decomposition of various sulfur containing substances in sewage. This decomposition also leads to evaluation of hydrogen sulfide gas, causing bad odor, besides causing corrosion of concrete sewer pipes. In aerobic digestion of sewage, the aerobic and facultative bacteria oxidizes the sulfur and its compound present in the sewage to initially form sulfide, which ultimately break down to the form of sulfate ion, which is a stable and unobjectionable end product. So, as just like free ammonia or nitrogen compound, the sulfide get converted into sulfate ions, that is the most stable form. In an anaerobic digestion of sewage, the anaerobic and facultative bacteria reduces the sulfur and its compound into sulfide, which evolution of hydrogen sulfate gas along with the methane and carbon dioxide, thus causing very obnoxious odor. So, in anaerobic condition, the sulfide get converted into sulfate and only hydrogen sulfide gas is evaluated or released. And in anaerobic condition, along with hydrogen sulfide gas, there is a methane gas and carbon dioxide are also generated, which are very obnoxious odor. The next chemical characteristics is dissolved oxygen. Dissolved oxygen is the amount of oxygen in the dissolved state in the wastewater. Its presence in treated wastewater effluent indicates that the considerable oxidation has been accomplished during the treatment stage. While discharging the treated wastewater into the receiving water, it is essential to ensure that at least 4 mg per liter of dissolved oxygen is present in it. If dissolved oxygen is less, the aquatic animals like fish, etc., are likely to be killed near the vicinity of disposal point. The presence of dissolved oxygen in wastewater is desirable because it prevents the formation of obnoxious odor. Dissolved oxygen determination also helps to find the efficiency of biological treatment. Next is biochemical oxygen demand. There are two types of organic matter. One is biodegradable or biologically active, and another one is non-biodegradable or biologically inactive. Organic matter is often assessed in terms of oxygen required to complete oxidize the organic matter to carbon dioxide and H2O and other end products of oxidation. Biochemical oxygen demand thus is defined as the amount of oxygen required by the microorganism to carry out decomposition of biodegradable organic matter under the aerobic condition. The BOD test is widely used to determine the pollution strength of domestic and industrial waste in terms of the oxygen that they will require if discharged into the natural water course. It is the one of the most important tests in stream pollution control activities. This test is of prime importance in regularly work and in studies designed to evaluate the purification capacity of receiving bodies of water. It is also useful in design of wastewater treatment plant and also to measure the efficiency of some treatment processes. The test is of prime importance in regulatory work and in studies designed to evaluate the purification capacity of receiving bodies of water. It is also useful in design of wastewater treatment plant and also measure the efficiency of some treatment processes. The organic matter present in the wastewater may belong to two groups: carbonaceous matter, nitrogenous matter. The ultimate carbonaceous BOD of the waste is the amount of oxygen necessary for microorganism in the sample to decompose the biodegradable carbonaceous material. This is the first stage of oxidation and the corresponding BOD is called as first stage BOD. In the second stage, the nitrogenous matter is oxidized by autotrophic bacteria and the corresponding BOD or nitrification demand. In fact, the polluted water will continue to absorb the oxygen for many months, and it is not practically feasible to determine this ultimate oxygen demand. Hence, the 5 days period is generally chosen for the standard BOD test, during which oxidation is about 60 to 70% complete, while within 20 days period the oxidation is about 95 to 99%. So that we are calculating the BOD value is for either for 20 days or 25 days. A constant temperature of 200 degrees centigrade is maintained during the incubation. The BOD value of 5 days incubation period is commonly written as BOD5 or simply a BOD. The sample is first diluted with known volume of specially separated dilution water. So this is the procedure of BOD test, how to calculate the BOD of sewage. So first stage is the sample is first diluted with known volume of specially prepared dilution water or distilled water. The dilution water contains salts and nutrients necessary for biological activity and phosphate buffer to maintain pH around 7 to 7.5. So the diluted sample is then incubated for 5 days at 20 degrees centigrade. The dissolved oxygen of the diluted sample after the incubation period is found out. The difference between the initial dissolved oxygen of the diluted sample after the incubation period is found out. The difference between the initial DO value and the final DO value, which will indicate the oxygen consumed by this waste sample in aerobic decomposition in 5 days. The BOD in milligram per liter or part per million is then calculated by using the equation BOD equal to DO consumed in the test by the diluted sample multiplied by volume of diluted sample divided by volume of undiluted sewage sample. So next important test or chemical characteristics is chemical oxygen demand. It is widely used as means of measuring the amount of organic matter in the waste. It can be used to measure both biodegradable as well as non-biodegradable organic matter. The chemical oxygen demand test, that is COD test, takes 3 hours in comparison to 5 days for BOD test. In COD test, strong chemical oxidizing agents like potassium dichromate is used in acidic medium to oxidize the organic matter present in the waste. Almost all type of organic matter, with a few exceptions, can be oxidized by the action of strong oxidizing agent under the acidic conditions. COD can be defined as the amount of oxygen required to chemically oxidize organic matter using a strong oxidizing agent like potassium dichromate under the acidic condition. So, up till now we have seen the physical and chemical characteristics. Now we will discussing on biological characteristics. What is meant by biological characteristics? The sewage contains many microorganisms like bacteria, algae, fungi, protozoa, etc. The bacteria being the most predominant. Most of the bacteria found in the sewage are harmless, non-pathogenic bacteria. They are helpful in oxidization and decomposition of sewage. A little number of bacteria, however, are disease-producing pathogens which are the real danger to the health of public. In case of sewage sample, the routine bacteriological tests as performed for the water sample are generally not performed because of the high concentration of bacteria present in it. But at the time of outbreak of epidemic, certain tests may be done to find the type of pathogens. So next important part in this unit is decomposition of sewage. So what is decomposition of sewage? The organic matter which is decomposed by bacteria under the biological action is called as biodegradable organic matter. Most of the organic matter present in sewage is biodegradable and hence undergo biological decomposition. which can be divided into two types. Aerobic decomposition, that called as aerobic oxidation, or anaerobic decomposition, also called as putrefaction. So what is aerobic decomposition? The aerobic decomposition is caused by both aerobic bacteria as well as facultative bacteria operating aerobically in presence of air or oxygen. So this is the most important terms, that is in presence of air or oxygen, which is available in the wastewater in the dissolved form. These bacteria will then utilize the free oxygen as electron acceptor, thereby oxidizing the organic matter to stable and unobjectionable end products. The stable end products like nitrate, carbon dioxide, sulfates are formed respectively for the three form of matter, that or three cycle, that is nitrogenous cycle, carbonaceous cycle and sulfurous matter. Water, heat and additional bacteria will also be produced in the biological oxidation, which can be represented by following equation. So the carbon, oxygen, hydrogen, nitrogen, sulfate in form of energy plus bacteria plus presence of, in the presence of oxygen, the decomposition in presence of aerobic bacteria or in presence of oxygen, it will get converted to gas of carbon dioxide and water molecules plus bacteria plus energy. The intermediate product formed in the aerobic oxidation of the three type of organic matter can be known by studying the nitrogen, carbon and sulfur cycle. So, as you can see in this diagram, so the nitrogenous organic matter present in sewage in form of nitrogenous organic matter in presence of oxygen, it will get oxidized or aerobically decomposed to form the ammonia or free nitrogen, that is NH3. So again it will get oxidized to form nitrite, that is NO2, and again by providing of oxygen it will get converted into its stable form, that is nitrates. So end product is nitrate. So nitrogenous matters in form of ammonia, which will get converted into stable compound, that is in nitrate. So this is the nitrification. And in denitrification or in absence of oxygen, again nitrate will get converted into free nitrogen. So again nitrates consumed by the plant, that is reconstitution through the photosynthesis, which will get or released into the air. Again some plant proteins are used this oxygen, and also the living animals which will use this oxygen, and after its death, that is the death of living animals and living plants, it will get converted into nitrogenous matter. So this cycle may be continued. So the previous one is nitrogen cycle, then this one is carbonaceous or carbon cycle. So in this cycle, the organic matter present in sewage in form of carbonaceous matter. So in the presence of oxygen, it will get converted into carbon dioxide, and the end product will be carbon dioxide, which will get released into the air, and ultimately after the death of animal and plants, it will get joined to the carbonaceous matter or organic matter present in sewage. The next important is anaerobic decomposition. So in aerobic decomposition, there are carbon cycle and nitrogen cycle. In anaerobic decomposition, if free dissolved oxygen is not available to the sewage, then the anaerobic decomposition called putrefaction will occur. The anaerobic bacteria and facultative bacteria operating anaerobically will then flourish and convert the complex organic matter into the simpler organic compound of nitrogen, carbon and sulfur. These anaerobic bacteria survive by extracting and consuming like nitrate and sulfate. Gases like ammonia, hydrogen sulfide, methane, etc. are also evolved in this decomposition, producing the obnoxious odor or bad odor. So as you can see in this figure, the sewage contains the nitrogenous, carbonaceous as well as sulfurous matter. So in absence of oxygen, it will get anaerobically decomposited, and it will get converted into first carbon dioxide and H2S. Then it will get converted into the ammonia when nitrogenous matter are present, and it will get converted to sulfide when sulfurous matters are present. And the end product of ammonia cycle is NH3, that is ammonia. Carbonaceous cycle is CO2, and the end product of sulfurous cycle is methane gas to produce methane, that is CH4 gas and hydrogen sulfide gas. So this cycle is continued just like a previous cycle. So in anaerobic decomposition, the methane gas is generated, which are not generated in aerobic decomposition. So stage-wise description of anaerobic decomposition you can see in this figure. So in stage 1, the organic matter present in forms of fats, cellulose and proteins. So in presence of oxygen, it will get decomposited to the soluble compounds. In stage 2, the acidic bacteria which will get decomposited this organic matter in organic acids, and ultimately in stage 3, the methanogenic bacteria which are converted these organic acids or organic matter present in terms of organic acids, which will get converted into the byproducts or end product in form of methane, carbon dioxide and water molecules. Thank you.